So this unit we're looking at standard position trig. So we want to use trigonometry, but we want to use it in standard position. So we want to use trig to find position, and we're going to use the XY axis to do this, and we're also going to use this circle, which allows us to go beyond 90 degrees. Okay, so when we talk about trig in standard position, we're going beyond triangle trig and using trig to locate positions in the XY plane on points along this circle, which allows us to look at angles beyond 90, 90 to 180, 180 to 270, 270 to 360. In fact, we can keep on going around that circle. Now, to define this then, the standard position is all about positioning. So it's this XY point. Okay? And to do this position, we need to establish our origin, okay, our 0, 0 here, okay, and the angle that defines the point. So we're going to start looking at defining this triangle shape or this point with an angle and with a ratio or position. So we did that before when I talked about 50 degrees. If I talk about a 50-degree triangle, most people can recognize that 50-degree triangle, that angle, we describe that angle by that turn. But we also look at 50 degrees by looking at the length here. We'll call that 1, and we'll say that's maybe about 1.1 or something like that. If I draw that, we're still talking about the same shape, okay? And this shape can be described with this ratio. It can also be described with a turn. So trig is about connecting those two things. And so what we're going to do is here, we're going to describe this point now, not necessarily the shape, but the point with either a standard position angle or an XY coordinate like we've done in the past. So to do this, we have to establish some things here. So when we talk about angles, we can have a positive angle and negative angle. So we can actually rotate in the positive direction this way, or we can rotate in the negative direction going this way. So when we talk about a negative angle and a positive angle, we're talking about two different positions. So how does right triangle standard position trig differ from right triangle trig? Basically, we can look at angles beyond 90 degrees. Whereas in triangle trig, we can't, because we can't go beyond 90 degrees in a triangle trig. So we can go into beyond 90 degrees. And more importantly, we are locating a position in the XY plane. Okay, so essentially we're trying to find out how to find that point on the circle. So we're going to extend our SOHCAHTOA definitions so that to more reflect a circle. So when we talk about sine, we talked about opposite over hypotenuse. Now we're going to talk about y over r, which is really kind of the same. The opposite is the y position, the radius essentially is the hypotenuse. But the difference is now we can accommodate negative y, so we can accommodate going down instead of just having a regular triangle. And in standard position trig, and in trig in general, we want to connect y to sine. If you do that, you will help yourself a lot when we start doing all the different trig. Sine goes with y, sine goes with vertical. Cosine, on the other hand, is adjacent over hypotenuse. Well, the adjacent side is your x side. Now, if we try to connect this idea too, that cosine and x go together. So when we talk about cosine, we're talking about horizontal. That will go a long way. And lastly, the tangent. The tangent ratio is y over x. Okay, opposite over adjacent, or y over x. Well, we know that y over x really is just slope. So we can think of tangent as slope. So essentially, tan theta is the slope because it's the y ratio over the x ratio. And this allows us to accommodate angles beyond 90, not just beyond 90, we can go down beyond 180, and we can allow us to accommodate all sorts of angles in that circle, all positions in that circle.